Today we're going to learn how to find the area of a parallelogram. Okay. First, we're going to start off by talking about what the definition of a parallelogram is. What is it? Okay, so a quadrilateral, and what quadrilateral means is that it has four sides. Okay, so a parallelogram has four sides with two pairs of parallel sides. Okay, I'll draw a picture of what this looks like in a minute. Opposite sides have the same length, which is important, and opposite angles have the equal measurements. That's not so important to us in 6th grade, but you will be using that when you get to higher math. Okay. And when we find the area of parallelograms, we're looking for the amount of space inside an object. Okay, so a parallelogram is something that may look like this. Notice how this side is parallel to this side. Those lines will never intersect. They are going straight across right on top of each other. Okay, and this side is parallel. The left side is parallel to the right side. Notice how that line is never going to intersect this line. It's parallel lines. Okay, the length of the top and bottom are also exactly the same. So if this is 10, just like a rectangle. And then if the left side is like 5, the right side is also 5. So that's what it means by opposite sides have the same length. Okay, so that is what a parallelogram looks like. Notice that a rectangle is considered a parallelogram as well as a square. Okay, because both those opposite sides are parallel and they have the same lengths in both rectangles and squares. Okay. So in class today we did an activity. So if you were absent, you kind of missed out on the activity, but basically what we did, okay, is we were given a parallelogram and we were cutting it up, drawing on it, manipulating it somehow in order to make it into a shape that we already knew how to find the shape area of. Okay, now my drawing is not perfect, all right, but so we were given a parallelogram. We were actually given this exact parallelogram right here. Okay, and students had to cut it up, and what we decided the most efficient way, the fastest and quickest way to make this into a shape, and easiest way to make this into a shape we already knew, was if we cut off that triangle right there. Okay, so if we cut off this triangle, and if we flipped it over here, okay, we now have this shape right here, which is a rectangle. Okay, we noticed at the bottom, and we just counted, the bottom of this rectangle was 12, and the height, the width of this rectangle was 8. Okay, and then we talked about where can we find those dimensions in this parallelogram that we were given, okay, that we were trying to find the area of, not just the rectangle, but the parallelogram. And we noticed that this base down here is 12 squares long, and this height from the bottom base to the top base was 8 squares tall. Okay, so we can see that 8 and 12 in this parallelogram as well. We talked about how when we found the area of this rectangle, we didn't take any squares away, we didn't add any squares to it. So the area of this rectangle is the exact same as the area of this parallelogram. Okay, because we didn't take any squares away. All right, so we got 96 for the area of that rectangle, and the area of this parallelogram is also going to be 96 because we didn't take any squares away, and we did not add any, we just moved it on over to over here. Okay, so to find the area of a parallelogram, we use a formula, base multiplied by the height. Okay, but we don't want to write out that word base every time. We don't want to write out that word height. So we do A equals, A for area equals B base times H for height. Okay, B times H. Here we're going to practice deciding what is a base and a height, because here we have 3 measurements and we only need 2 of them. We only need the base and the height. Okay, the base is going to be one of the sides of the parallelogram. So our option here for the base are 16 or 10. Okay, that base is going to be the base that the height is connected to. Well, the height is straight up and down, okay, from one base to another. So the height is 8 centimeters. The base is 16 centimeters. Okay, try this next one on your own. Pause the video, and then resume it when you're ready to check. The base of this parallelogram right here would be 20, inches. And the height is straight up and down 14. Notice how this height is not 17. Okay, 17 is not straight up and down. See how it's slanted? Okay, our height is always straight up and down. Okay, or straight left to right. It could be flipped, which we'll see in an example below. Okay. To show our work for the area of a parallelogram, we have to be very picky. Okay, on a quiz, test, things like that, each one of these problems is going to be worth 3 points. 1 for writing the area formula, area equals base times height. 1 for using substitution, so putting in the number for the base. So for example, up here it would be 16 times 8, putting in the number for the height, and then writing your answer with the correct label. Okay, and that is where you're going to get those 3 points. So if you only write the answer with the correct label, you're missing 2 out of those 3 points for every single question. Okay, that'll end up failing you on a quiz or test. So make sure that we're showing our work this way. So our very first step is base times height. All right, our base here is our bottom side of the parallelogram is 16. And our height is straight up and down from that 16, which is 22. All right, so we're going to take 22 times 16 to the side. I'm going to add a 0 because I'm moving on over to that tens place. Add them up. I get the answer of 352. Now number 3 says that this answer is not right. I need to put a label. This is inches squared. Okay, the reason that why it's inches squared is because it's 16 times 22 gives us the 352. But it's 16 inches times 22 inches, so it's also inches times inches, which is inches squared. Number 4 is a little tricky, okay, because it is a parallelogram like this that's just rotated up on its side. Okay, so finding that base and height is a little bit harder. Well, I think finding the height is the easiest because it connects 2 bases and we don't have a line that's going straight up from that base to that base. We have a line going from this base to this base. That's going to be 8. Okay, and the base that is touching, excuse me, the base that is touching is our left and right side. Okay, so those are going to be the bases we're using, the base, height. So we have 12 times 8 here. Another method you could do to find the base and height when it's rotated is you could rotate it back. Okay, so we have a parallelogram that looks like this. This would put 12 on the bottom, 8 going up, and 10 on the side. In this parallelogram, we then see that 12 is our base and 8 is our height. Another method you could use, if we're struggling with finding what that base and height is cut this triangle off, just like we did in our activity, and replace it over here. Okay, so we now don't have this here, and we're finding the area of this rectangle, which we learned in our activity is the exact same area as that parallelogram we started with. Now the dimensions of this rectangle are 12 by 8, so we have to do 12 times 8 to find the area of the parallelogram as well. Okay, when we do 12 times 8, we get 96 feet squared. Right now I'm going to explain example number 5 to you, and then I want you to try it on your own, pause the video, and then resume it to check your answer. All right, so first listen to the instruction. All right, so what you're going to do here is, here we have a parallelogram. You're going to say, what is the base? What is the height of this parallelogram? Then we want to choose either rectangle A or rectangle B for which rectangle has the same area as that parallelogram. Okay, if it has the same area, it's going to have the same base and the same height as this parallelogram. So at this time, I'd like you to pause the video, determine what the base and height are, and then make a guess if you're not quite sure on which rectangle is going to have the same area. And then resume. Okay, so our base of this parallelogram is 13. Our height going straight up from that base is 7. 13 meters, 7 meters. Which one of these rectangles has a 13 and a 7 being labeled for those length and width? That would be rectangle B. Okay, we don't even have to solve it because 13 times 7 for a parallelogram is going to be the same thing as 7 times 13 over here. Okay, so we know that those areas are going to be the same. We don't even have to solve it. Down below, I'd like you to write a summary on how you find the area of a parallelogram. It could be short and sweet, or you could go into depth. That is up to you. But just make sure you summarize it so that you remember how to do this.